Good evening, everyone. Welcome to Grow Up Online Tuitions and welcome to the class of Ncert line-to-line explanation of haloalkanes and haloarenes. In this video, we are going to discuss about the methods of preparation of haloalkanes. In this video, we are going to discuss about the preparation of haloalkanes only from alcohols. In the next videos, we are going to discuss about the various type of preparations of haloalkanes. Okay. Now let us try to understand before going to discuss about these. Now let us try to understand these reactions first. Okay. Now let us try to understand the firstly reactions. Before going to discuss about this paragraph, try to understand these reactions. Then we can easily understand the above and below paragraphs. Okay. Now let us try to understand the given reactions. Here we observe that when alcohol is reacted with the concentrated HCl in the presence of ZnCl2, that means zinc chloride, it gives rise to the alkyl halides plus water is produced. Now let us try to understand its mechanism first. This mechanism can be understood by taking of an whiteboard. So we observed that we previously observed reaction is called the locus reagent. We previously observed reaction is called the locus reagent. Locus reagent. Now let us try to understand what is meant by reaction. Here, when alcohol is reacted with concentrated HCl in the presence of anhydrous ZnCl2, it produces alkyl chloride plus water. Here we observe that by using of these two concentrated HCl and anhydrous ZnCl2 is called as an locus reagent. This reagent is very important with respect to exam point of view. What is the main use of this reagent? Now let us try to understand what is the use of this reagent. This reagent, the main use is that distinguish the this reagent is used to distinguish the primary, secondary, and tertiary alcohols. Primary, secondary, and tertiary alcohols. The main use of locus reagent is used to distinguish the primary, secondary, tertiary alcohols. Now let us try to understand this locus reagent mechanism. You can okay. Now let us try to understand its mechanism. First of all, you have to understand what does mean by anhydrous ZnCl2. Why anhydrous ZnCl2 is used? Why anhydrous ZnCl2 is used? Try to understand this question. Here anhydrous means we already know that without water. Anhydrous which means without water is called the anhydrous. We call it as an anhydrous. So why anhydrous ZnCl2 is used? Why? Because here we observe that anhydrous ZnCl2 is a Lewis acid. Lewis acid, that means we know that every compound is stable when it has the 8 electrons. 8 electrons, that means satisfy the octet rule. Here does not satisfy the octet rule. That's why ZnCl2 is act as an electrophile. So here we observe that R bond OH. The OH group which is present is not a good living group. Is not a good living group. That's why we use the ZnCl2 as a Lewis acid. Lewis acid is reacted with alcohol. It forms the complex. It forms the complex ion. It forms the complex ion which act as a good living group. I hope this concept is clear to you. Why we use the anhydrous ZnCl2 is that here we observe that this OH group is not a good living group. That's why this alcohol group is reacted with anhydrous ZnCl2, then it forms the complex nature, the complex which is easily removed as an easily as a good living group, easily released as a good living group. So we can obtain carbocation. So when OH group is released with the ZnCl2, That means R plus. That means carbocation is produced. We produce the carbocation. So the HCl, the Cl minus from the hydrochloric acid, then R plus and Cl minus form the RCl. We required haloalkane is produced. Our required haloalkane is produced. Now let us try to understand its mechanism. Now let us try to understand its mechanism. Okay, alcohol. Here is the alcohol is reacted with anhydrous ZnCl2. We know that we previously know that ZnCl2 is an Lewis acid. So it accepts the electrons. So it accepts the electrons. So here we observe that oxygen having the lone pair. Oxygen donates one of its lone pair to anhydrous ZnCl2. That's why it forms the complex. It looks like R. We observe that the bond between oxygen and zinc is formed. R bond hydrogen. Here hydrogen is present. Here one lone pair donates. That means it indicated by positive charge and another lone pair is indicated here. So the bond between oxygen and zinc. The remaining chlorine retains its position. So here is the complex. Here is the complex formed. Here is the complex is formed. So R plus to neutralize this positive charge, the bond between alkyl group and oxygen shifted towards this side. So we form the R plus Zn OH and Cl2. This here act as a OH. Here is the OH. Here we observe that this is the good living group. This is the good living group. This is act as a good living group. So we produce as the carbocation. We produce as the carbocation. This carbocation is reacted with the HCl. That means H plus and Cl minus. R plus and Cl minus form the R bond Cl. We produce as the alkyl halide are simply called as haloalkanes. Both are same. Alkyl halides are haloalkanes. Both are same. Plus water. Plus water is produced. This is all about the mechanism of locus reagent. I hope locus reagent is clear to you. Why do we take the anhydrous ZnCl is taken? Why? Because it forms the why? Because OH group is not a good living group. To act as a good living group, to react with anhydrous ZnCl2. Here is the complex is formed when alcohol is reacted with anhydrous ZnCl2. So in this reaction, carbocation is formed. This carbocation is reacted with HCl. It produces the alkyl halide or haloalkanes plus water. Okay. Now let us try to understand important points. Now let us conclude this locus reagent by keeping the by important points. Okay. Locus reagent. What are the important points to remember according to the locus reagent? The first question is that why we take an anhydrous ZnCl2? Why we take an anhydrous ZnCl2? We absolutely know this answer. Why? Because the alcohol group, the in alcohol group OH is not a good living group. That's why it react with anhydrous ZnCl2, which act as a Lewis acid. It forms the complex. That's why it act as a good living group. Okay. And which intermediate is formed in locus reagent? Intermediate formed. Which intermediate is formed in locus reagent? We absolutely know that the intermediate formed is carbocation. The intermediate formed here is a carbocation. So the next question is that by locus reagent, which products are formed? By locus reagents, in locus reagent, which products are obtained? Which products are obtained? Which products are obtained? Here is the answer that we obtain haloalkanes or alkyl halides or haloalkanes. This is all about the locus reagent, which was very important with respect to the exam point of view. Now let us try to understand how this reacted with the primary, secondary, tertiary alcohols. At the starting of this video, we discuss about that the locus reagent which is used, the main purpose of this locus reagent is that to distinguish the primary and secondary alcohols. Now let us try to understand how this locus reagent distinguishes these. Okay, here is the locus reagent. Here is the locus reagent. So when this locus reagent we means, which means concentrated HCl plus anhydrous ZnCl. To concentrated HCl plus anhydrous ZnCl is called the locus reagent. When this locus reagent is reacted with the primary alcohols. Now let us take an example of CH3, CH2 bond CH2 bond OH. This is considered as this we consider as the primary alcohol. When locus reagent is reacted with primary alcohol, the solution remains colorless. The solution remains colorless unless it is subjected to heat. Unless it is subjected to heat. Here we observe that when this locus reagent is reacted with primary alcohols, the solution becomes colorless until it is subjected to heat. So the solution forms the solution forms an oily layer. The solution forms an oily layer when heated. The solution forms an oily layer when heated. You have to keep in mind that by heating it forms the oily layer. So we conclude that when locus reagent is reacted with primary alcohols, it forms a colorless solutions, remains colorless until it's subjected to heat. The solution forms oily layer when it is heated. When it is heated, only in case of heating the oily layer is formed. Now let us try to understand the secondary alcohols. How does a locus reagent react with the secondary alcohols? For example, CH3 bond CH bond CH2 bond CH3 bond OH. Here we consider that this is the secondary alcohols. Okay. The solution the solution turns turbid. The solution turns turbid and forms a oily layer in 3 to 5 minutes. In 3 to 5 minutes. We have to observe comparison that when locus reagent is reacted with primary alcohol, when it is subjected to heat, then only forms oily layer. But in secondary alcohols, it forms the oily layer within 3 to 5 minutes. Now let us see the how this reacted with the tertiary alcohols. We can take tertiary alcohol example CH3 bond C bond OH bond CH2 bond CH3 bond CH3. Okay, the solution turns turbid and forms oily layer immediately and turns oily layer immediately. So turns the oily layer immediately. So we observe the comparison here that so we observe the comparison that when locus reagent is reacted with primary alcohols, it forms only oily layer when it is subjected to heat. But in secondary case, it forms an oily layer within 3 to 5 minutes. But in tertiary case, it immediately forms the oily layer. So this is the differentiation of primary, secondary, tertiary alcohols by using of locus reagent. I hope this concept is clear to you. Locus concept is clear to you. I hope the first reaction is clear to you. In the next video, we are going to discuss about the remaining mechanisms. Okay, I hope this concept is clear to you. If you have any doubt in this concept, please WhatsApp me. I will available in WhatsApp, and you can directly call to me. Okay, in the next video, we are going to discuss about these mechanisms. Why? Because these mechanisms are very important. If you explain all these mechanisms in a single video, it cross the 1.5 hour. That's why I will conclude up to this. In the next video, we are going to discuss about the remaining mechanisms. Thank you and all the best.